screen for the size of the church here.
Is this Tom? Tom, is this yours?
Oh, that's my, thank you, Doug. Thanks. Good to see you.
On behalf of President and the Provost of Lewis University, I would like to thank you for coming today. My name is Christopher White. I am the Dean of the College of Aviation, Science, and Technology. As a lifetime educator, I've been taught to let everybody know what the learning objectives are. So, today, what we hope for you is that you'll learn about climate science, you'll learn about the climate disruption that's happening today, and you'll learn about how this is impacting humans worldwide. More importantly, when you walk out, I hope that you will understand that this is not an esoteric physics topic or science topic that's happening in classrooms, but this is a real thing that's happening today, the pace of which is ever accelerating. And as a consequence, it's impacting hundreds of millions, if not billions of people. So I appreciate the fact and thank you for deciding that this is an important issue for you to be here today. Our moderator today is Congressman Lipinski. Congressman Lipinski is a longtime friend of Lewis University. Congressman, thank you. He is also He also sits on the Committee for Science, Space, and Technology and the Subcommittee on Research and Technology. So this is an important issue for him in Congress. He believes that innovation and exploration should not come at the expense of the environment. And as a lifetime educator himself, he strongly believes that education is a solution. So without further ado, I introduce to you your moderator for today, Congressman Lipinski.
Thank you. I want to start by thanking Lewis University for hosting and welcoming us, providing this site here. So thank you to Lewis. I also want to welcome and thank our panelists for being here today and sharing their expertise with us. We also have, I want to mention State Representative Natalie Manley is here today. So thank you for joining us. And finally, most importantly, I think, I want to thank you for taking the time to be here today, because you understand what a critical issue climate change is, and you want to learn more about it so we can go out there and have educated conversations about what's happening, why it's so critical that we do something right now. Now, it's especially great to see young people here, because I was a child in the 1970s. So the environmental movement really, was very strong at that time. My favorite book, I remember when I was a kid, was Captain Ecology. And I had this book sitting, I had it sitting on my kitchen table, and I forgot to bring it with me. I was going to be so proud to show the Captain Ecology book. I don't have my original version. I found it online a couple years ago, and I was so excited to find that. It's Captain Ecology, Pollution Fighters, published in 1974, and the subtitle is The Adventures of a Superhero with a Social Conscience. So I always wanted to be that superhero. And now I sort of get to do that as a member of Congress. At least I try. Before I ran for Congress, I was an engineer, and then a political science professor. I won't get into how that transition happened, but I was trained both as an engineer and a political scientist to scientifically analyze problems and develop solutions. When I first was elected to Congress, I immediately joined the Committee on Science, Space, and Technology, and where we listen to experts talk about issues, talk about the evidence, talk about innovation, and trying to come up with solutions to big problems that we face. And clearly, climate change is at the top of the list right now. The first two bills that I introduced that were passed into law all the way back in 2007 had to do with lowering greenhouse gas emissions. In 2009, we thought that we could do something in a comprehensive bill to address climate change. We passed the cap and trade bill in 2009 in the House of Representatives. But unfortunately, it didn't go anywhere in the Senate. 2009, I also joined two Republicans to introduce a bill to institute a carbon fee, which then would be fully refunded through other tax breaks. And I'm always looking for solutions, things that we can bring people together to get stuff done. So that was the first time there's actually a bipartisan bill to address climate change. Unfortunately, over the last decade, there's been no major piece of climate change legislation passed. This last year, I introduced another carbon fee bill. Again, it's bipartisan, but honestly, and we won't get into the politics of it, it is a very, very tough issue on the other side of the aisle. I'll just say that. But the lack of action in Congress needs to end. And if we are going to motivate members of Congress, legislators, and motivate a president, we need, as I always believed, we need to be armed with knowledge. If we're going to motivate people, we need to know what we're talking about. Because you go out there with the facts about what's going on, why this is a big problem, and what we can do about it. And that's why I brought together this panel of 5 experts here today, so they could arm us all with that knowledge. So I want to begin by introducing our 5 panelists, and this is not in order. The order changed a little bit from when I had this, and not to confuse myself or anyone else. I'll read it in the order they originally had. So we have Dr. Laura Franklin, who is the Dean of College of Humanities, Fine Arts, and Communications here at Lewis University. If you're a student here, you know that she is a trusted member of the community, a gifted communicator, and is valued for her ability to build partnerships. We also have Dr. Seth Darling, who's Director for Molecular Engineering and Senior Scientist at Argonne National Laboratory, just down the road from here. He can share from his 20-year career working at the Center of Midwest Innovation ideas about possible solutions. We also have Doug Cistern, who is a research meteorologist focused on climate change, just retired from Argonne National Lab, and currently teaching about climate change science at North Central College. Dr. Don Wubels is now the Harry E. Preble Professor of Atmospheric Science at the University of Illinois, and was the Assistant Director in the President's Office of Science and Technology Policy from 2015 to early 2017, serving as a climate expert in the White House. He has also co-authored and led on several international climate assessments, including the Intergovernmental Panel on Climate Change Assessments, which led to a Nobel Prize in 2007. And the man who everybody knows, and I knew he was walking in the room. People saw him as soon as the cheers started rising from the crowd. We have Tom Skilling of WGN News. this event arose from a conversation that we had. Tom and I were at a fundraiser for a scholarship fund at Lewis University, which Tom has been so kind to MC for the last few years. And we talked about the possibility, because I know Tom has done these before. David Livingston, who's president of Lewis, was also there, and the three of us talked about it and said, we need to do this here at Lewis University. So I'm very honored to have Tom come here to do this. One of the most famous weathermen in the world. The fact that he is putting his free time into educating people, and he's the one who brought this panel together here, in putting this all together to educate all of us and educate the world on climate change. So thank you very much, Tom, for doing that. And we are going to start the first person. We are going to start with Doug Cistern.
It did work, okay. So, the screen is way over there, the podium's way over here. How's my teacher voice? If I do this, do you hear me? Yeah. Okay, I'll start here.
Doug, here.
Oh, we have one. Will this work?
It's being streamed.
Is this, oh, perfect. Oh, perfect, okay, thank you. So, I'm going to go through you what I teach in about 4 weeks in about 10 minutes. So it's going to go pretty quick. But basically, the greenhouse effect. I assume that most of you know what that is. But basically, the sun shines its radiant energy to Earth, heats up the Earth. The Earth tries to radiate that energy back to space, but it gets trapped by what we call these greenhouse gases. So it works much like a greenhouse, hence the name. What people don't really realize, if we didn't have any of these greenhouse gases in our atmosphere, the temperature of the Earth would be 0 degrees Fahrenheit. 0, because we give all the energy from the sun during the day, give it back at night, nothing to trap it. But because we have greenhouse gases, natural greenhouse gases before the Industrial Revolution, the Earth stays at a balmy 59 degrees Fahrenheit. So the difference between 0 and 59 degrees is these greenhouse gases, and there's only 0.05% by volume greenhouse gases in the atmosphere. 0.05. That's actually the difference between 0 and 59 degrees. So the point is, don't go messing around with greenhouse gases. Well, that's what we did. We didn't mean to, but we found out if you dig up coal and you burn it, it gives you a really cheap energy source. It's great. We all like electricity. But the problem is, when we burn it, we get carbon dioxide into the atmosphere. As early as 1800s, scientists said, you know, as we get into this industrial revolution, we could be affecting the Earth, the temperature of the Earth. That could happen. So we had some scientists thinking about that early as the 1800s. It wasn't really until the 1950s that technology caught up, modeling caught up, supercomputers caught up, and we could start to understand the science. And the deal was that we started to realize that something's happening here. And whoops, wrong thing. If you look at the graph, let's see if I'm going to do this right. I don't want to turn it off. Does the marker work? Yes. So here's the last 1,000 years. And we're kind of cruising along with carbon dioxide kind of varying a little bit, but not a whole lot. Temperature is wavering a little bit, but it's still within what we would call sort of normal. And all of a sudden, here about 1900, all of a sudden, the temperature starts shooting up, the carbon dioxide shooting up. And scientists started raising the red flag. We had data. We said, something's going on here. There's some warming going on here, and it's alarming. And we, since the Industrial Revolution, realized that the Earth increased about 1 degree C, 2 degrees Fahrenheit since then. And we claim it's because of the amount of anthropogenic or human-made burning of fossil fuel, CO2, we put into the atmosphere. Oh, where's it? Hello? There we go. So a lot of people always say, well, okay, we see this change is going on now. We can even describe why that's happening now, why it's even important. But we say, well, what about the past? Has happened before. How do we know it's not one of those? So if we want to start from the beginning of the Earth, at 4.5 billion years ago to about 2.5 billion years ago, the Earth didn't look anything like it looks now. It was molten lava. It was this fiery ball. But eventually the Earth did begin to cool, and land masses could begin to form, and oceans began to form. But the atmosphere was mostly greenhouse gases, so it was much warmer than just the energy from the sun. It was about 2.5 billion years ago that we start to get a certain type of bacteria that would put oxygen back in the atmosphere. That was the first sort of beginning of photosynthesis. So oxygen was starting to replace greenhouse gases in the atmosphere. So it started to make the atmosphere cooler. So we can go back and we use something we call paleoproxies. These are things that we didn't certainly have thermometers back at 500 million years ago, but we can look back through rocks, and we can not carbon date them, but we can use lead dating or uranium dating, and we can come up with understanding fossils that might be up to 500 million years old. We look at those, and we can make some really educated guesses about what the temperature must have been on the Earth to support this type of a fossil, of a plant. And so we were able to go and construct in this graph. I know it's probably going to be hard to see for everybody, but the idea is that it starts here about 500 million years ago to about 100 million years ago. Then there's a break in here, because if I did this graph, it would be longer than the rest of this room. So basically, here's a period of our history where the temperature is fluctuating all over the place. And you can see here we are now. It's been much warmer than in the past than it's been in the future. And we see these huge fluctuations. Well, the sun is changing its energy output. We're getting large hunks of bigger than meteors hitting the Earth, which is starting to build up land masses. And when they hit the Earth, they cool the Earth because they put up big ash clouds. And sometimes the meteorites trap some of the carbon dioxide. It's trapped in the layer of the atmosphere as it's cooling and the surface of the Earth. So it does a lot of back and forth. And then we start to get into this interesting period where we start to see dinosaurs. We started getting plants that could support growth, and the dinosaurs were here, and dinosaurs breathe. That's called respiration. They gave off carbon dioxide. Okay, here we go again. We're going to start to warm the atmosphere. And then this big meteorite came, and it actually started, hit the Earth and made it very cool because of the cloud of ash to cool off the Earth. And suddenly, the Earth got cold, dinosaurs disappeared. So there's a little dip here, and then all of a sudden, the ash goes away from the clouds, and the sun starts coming out. Greenhouse gases start going up again. Well, what's this all about? It turns out that we started having mammals, and the respiration was coming back. And so we got to a peak sort of in the Earth's early history of a thermal maximum, which is certainly a lot warmer than it is today, about 14 degrees centigrade warmer. And it turns out at this point, we started to see that the temperature in the Earth's atmosphere started to decrease. Temperature and carbon dioxide are kind of related. So we expect sort of this behavior as we started to see more and more plants growing photosynthesis, taking up more of the carbon dioxide coming from respiration of animals, and suddenly the planet is cooling because we're replacing greenhouse gases in the atmosphere with oxygen. So we get down here to a point where all of a sudden we see a lot of these little wiggles, but they seem to be coming about every 100,000 years. They're called the Milankovitch cycles. And it turns out that the Earth is not in a perfect orbit around the sun. It's not a circle, it's elliptical. So sometimes we're closer to the sun, it's a warmer period. Sometimes we're further from the sun, it's a colder period. Colder periods form glaciers. We call that the glacial periods. The warmer periods were the interglacial periods. And so this happened for about 1 million years. This is up to 1 million years ago, and we know that really well because we have ice core samples where we could do the chemistry and look at temperature and a lot of the constituents of the atmosphere. So we feel really good about that. But all of a sudden, Mother Nature's working here to still find a balance between the sun and the greenhouse gases in the atmosphere, and we get to a point where we get the last 20,000 years. Now, we had some interruptions of volcanoes. Volcanoes do cool the atmosphere, but here we are about 10 to 15,000 years ago, and you can see at this point where the temperature's sort of stable, the carbon dioxide is stable. We kind of think that in modern day, that's kind of when finally after 4.5 billion years, Mother Nature got to the planet to the way we understand it today. It could support life. It doesn't change a whole lot, and everything's in balance. That is until about the 1900s when we started putting carbon dioxide back into the atmosphere because we started burning fossil fuels. So the whole point of this is that we can go back through history, a lot more detail than I've just given here, and we can explain a lot of what's going on. And you know what? There weren't a lot of people back then giving us burning carbon dioxide. This is different. This is a different time in our history. And current climate science says there's nothing in the past that can explain that of what we're seeing today. So this carbon cycle is really important. Carbon is the thing, the carbon cycle depends how much greenhouse gases are in the atmosphere. And it turns out that if we look at this historically, that Mother Nature was able to come up over 4.5 billion years a way to cycle the amount of carbon dioxide that was naturally coming from the planet through breathing and respiration and all the different functions of way the carbon in the atmosphere is taken out of the atmosphere and put back with land, bioatmosphere, and oceans. And if you look at these numbers, they're basically balancing. That means that Mother Nature was in harmony with the sun and greenhouse gases. At 59 degrees, Earth was happy. But here we came along and we started dumping carbon dioxide back into the atmosphere. It's not as much as the carbon that's naturally in the atmosphere, but Mother Nature didn't have anything it could do with it. It was just getting stuck pretty much into the atmosphere, and that was what was causing the temperature to increase. So the bottom line is, after all of this, the first sort of 4.5 billion years was Mother Nature trying to make this a planet that you and I now can enjoy. But the last 150 years after the Industrial Revolution, something happened. We came along, we dug up all that carbon that Mother Nature safely tucked away in the ground. We dug it up and we burned it. So basically, the first 4.5 million years is on Mother Nature. The last 150 years is on us, and we call this the Anthropocene. Welcome to the Anthropocene. Thank you.
Thank you. Thank you, Doug, and Dr. Don Wubels.
Yeah, welcome, everybody. I'm Don Wubels. I'm a professor of Atmospheric Sciences, University of Illinois, but I'm also a farm boy from Southern Illinois, so that's always there as well. What I'm going to do today is just give you a quick overview of what's been happening to our climate over the last century and what's going to happen potentially over this century based on what the projections are for different scenarios for continuing burning fossil fuels, continuing changes in land use. It leaves out some of the feedbacks that may actually make the climate change even worse, and we could talk about that later. So every year there's about 12,000 papers written in the peer-reviewed literature. This is how scientists judge ourselves we try to publish new knowledge in journals and through scientific papers. And these papers are then judged by our peers before they're allowed to be published. Well, that creates a lot of knowledge and the need for special assessments of that knowledge to understand what is really happening to the climates in this case. And so that led to the formation of the Intergovernmental Panel on Climate Change. I was a coordinating lead author in the very first assessment in 1990 and have been on a number of the ones since. The picture on the left there is the first volume on the science of climate change from the 5th International Assessment, and that was published in 2013. There's a current assessment going on to be published in the next 2 years. About that same time period, Congress passed a law called the U.S. Global Change Act that requires that the U.S. also look at what is happening to the climate and what that means to the American people. We just completed a couple of years ago now, the 4th National Climate Assessment. I led Volume 1, which is the middle picture there from the front page, and showing an atmospheric river heading into California that ended the drought in California in 2016. And that looked at the science of climate change. The second volume looks at the impacts in American people, and I was also heavily involved in that. And you can get both of those volumes online. In fact, you can get all of this online. But the question is, what do these assessments tell us? Well, what do we learn? As you heard from Doug, our climate is changing. It's changing really rapidly. In fact, it's changing about 10 times more rapidly than nature tends to change the Earth's climate system. That's really important because it makes it really difficult for humans and animals and plants to adapt to that change. And that's one of the reasons why we're struggling with some of the changes happening worldwide right now. It's not just about temperature. You know, you hear global warming in the media because the media likes that term. Scientists have always called it climate change. And the reason for that is because it's really about what's happening to severe weather. We're getting more intensity in many different types of severe weather, getting more very hot days, extreme heat days, but we're also getting more extreme precipitation. So when it rains or snows, it's more likely to come as larger events. Storms are becoming more intense. Hurricanes becoming more intense. A number of different aspects, and I'll probably won't have much time to get into all that. But on top of that, because of the warmer temperatures, the oceans are also warming, and that's driving an expansion of the oceans, sea level rise. But on top of that, with all the melting ice on land from glaciers throughout the world, but also particularly what's happening in the Arctic and Antarctica, we're seeing a significant change happening in the oceans. And that potentially can lead to very significant changes, 1 to 4 feet increases or more in sea level over this century around the world. And as you heard from Doug, this is largely happening because of human activities. In fact, if I had to do an analysis like we did in the 4th National Climate Assessment of what has caused the changes over the last 60 years in the Earth's climate, it's entirely due to human activities. There's natural variability in the climate system, but that cannot explain what we're seeing. And it's not the sun. The sun has actually not changed very much at all in that time period. If anything, it's actually decreased slightly in its emission. The other thing we know is that the climate will continue to change over the coming decades. So the globally average temperature, many, many thousands of temperature observations taken with thermometers throughout the world, both above the oceans, over land, every day. Those are put together by various organizations, including NOAA and NASA in this country, the UK Meteorological Society, and our Met Office in the United Kingdom, and several other organizations around the world as well. They all come up with the same thing, that the global temperature has changed about 1 degree centigrade, 1.8 degrees Fahrenheit to this point over the last century, and that change will continue as we look in the future. We'll look at that in a second. With most of that change happening in the last 50, 60 years. 2016 was the warmest year in record, followed by 2019, actually. This last year was the second warmest. 2017, 2015, then 2018, then 2014. As you can guess, this last decade was the warmest decade on record since we started really taking useful global measurements in the late 1880s. So we are seeing something very unusual in human experience. Oh, on the bottom is going back using some of the paleo data for the last 2,000 years, and it shows that the current temperatures are well above what humans have experienced on this planet over the last 2,000 years. And yet you can see the medieval warming period when the Vikings were in Greenland. And you can see a slight bump up there during that time period. And you can see the little ice, what's called the Little Ice Age, when it was extremely cold in North America and Europe and parts of China, which appear to have been largely related to very large volcanic eruptions that occurred during that time period. So I've mentioned some of the things happening with extreme events and that those are likely to continue. Because I did that, I'll skip over that. How do we know those things are important? Well, if we go back to 1980, for the US, and there's similar analyses done for the world. NOAA, the National Oceanic Atmospheric Administration, has been tracking what are called billion-dollar events. These are events that cost $1 billion in infrastructure. This doesn't count for inflation every year, so that's out of it. And when you first started looking at this time period since 1980, the first decade or so, you were seeing a couple typical events per year. Now we're seeing 15, 16, 14 such events every year. This past year was 14 such events. And so we've seen this very significant increase in the effects on the American people. And it's happening to all parts of the country. So it's not just hurricanes, it's all kinds of different types of events. And in fact, this last year where there was a very significant effect in the Midwest because of the impact on the farmers from the huge amount of large precipitations that happened last spring that they couldn't get their crops into the fields. And so this is the thing we're really concerned about. And so far, if going back over this almost 40-year period, we've seen over $1.5 trillion effect on taxpayers. So you can say a couple of these per year are just would have occurred anyway, they're natural. But this increase is related to the fact our climate has changed, there's more energy in the atmosphere, and it's driving more significant type events than we've had in the past. And so climate change is affecting you. It's affecting your pocketbook through what you pay as taxes. You just don't realize it. Now, I'm going to switch and mostly talk about, for a little bit about the Great Lakes region. I led a special assessment this last year with 18 other scientists looking at, or 18 total scientists, across the US and Canada, looking at the Great Lakes. We concentrate primarily on the US side, but in this assessment, and I do have a couple copies of that assessment with me if anyone wants them, and you can also get it online through the Environmental Law and Policy Center in Chicago. So if we look at the projections for temperature changes for the future, it really depends how much we continue to burn fossil fuels, how much continued changes in land use. And so we look at a wide range of different scenarios for that, just as we did in the National Climate Assessment and in the IPCC assessment. We seem to get accused in the media these days of only having looked at a large business as usual assessment. First of all, none of these scenarios are business as usual, but some are higher than others because they assume we'll continue to still burn fossil fuels into the future. Right now, we're on the very highest scenario in terms of our emissions, which means we are burning fossil fuels faster than some of these other scenarios say we already should have been starting to drop by this point. But in this assessment, we looked at the high scenario, and we're looking at towards the end of the century here. I've also looked at the mid-century, and a lower scenario. And that lower scenario assumes that we heavily change away from fossil fuels by mid-century as a people around the world. And you see a large difference in the temperature changes. Colors there show you that for the Great Lakes states, the states touching on the Great Lakes, that we can see differences between 4 and 5 degrees Fahrenheit increases over this century versus the high scenario where we're seeing 8, 9, 10 degree changes. So we're still going to see change, and change we're going to have to adapt to, but the change isn't as large if we make the choices to go with the lower scenario. Precipitation has already increased about 10% in the Great Lakes region over this last century, and much of that increase has become as larger events, as I mentioned earlier. Projected increases in precipitation for this century are as much as another 10% or so. Again, with more and more of that coming as larger events. And if you look at the that larger events things, 19% more of that precipitation for a 5-year return increase over the coming decades. We'll talk about Great Lakes fluctuations themselves in a minute. Looking at snowfall, total snowfall in the Great Lakes is overall likely to decrease over this century under either of the scenarios, more under the high scenario than the low scenario. But lake effect snowfall could actually increase. As the lakes have less ice on them, you get more evaporation, more water available for snow downstream. Now, looking at the Great Lake temperatures and fluctuations, summer water temperatures in the Great Lakes have already increased pretty significantly in some places over the last 6 decades, and that is expected to continue. Water, as you all know, water levels have fluctuated considerably over multi-decadal timescales, and this will continue to do so. At least that's what we concluded in the assessment. However, my latest thinking is that with these projections in precipitation increasing and more of it coming as larger events, that we really need to study this more carefully. We could be in a situation where the scales have tipped towards higher lake levels. We need to look at this more clearly with the best tools we have available. And in fact, scientists at Argonne and I have been talking about doing just those kind of studies. Current global scale emissions and climate policies are not consistent with sustainability. We need to reduce emissions. The graph on this side just shows that current emissions and those projected under the current version of the Paris Agreement are insufficient to get us towards that low scenario I was showing in the previous graph. And certainly not be able to reach the 1.5 or 2 degrees centigrade levels that is heavily desired under the Paris Agreement. I've almost given up on our ability to reach those. But can we reach that low scenario I was showing you, which is still 3, 4, about 3 degrees centigrade, so 4 or 5 degrees Fahrenheit, that is still possible. Well, what can we all do? I get asked this constantly in my many public talks about climate. The best thing you can do is talk to your representatives. Talk to Representative Lipinski and his colleagues in the House. Talk to the representatives in the Senate. Talk to your local representatives. Tell them why this is important to you, your children, your grandchildren, and why this really makes a difference. Vote with care. Speak up yourself. There's a lot we can be doing. Thank you. We can also be doing a lot in our own homes and our own lives, and many different ways, just including doing things like using more efficient light bulbs to try and have more efficient vehicles, or putting a solar system in the house. That is a picture of my house with its solar system. I think it's important under these very trying, difficult situation of a changing climate to keep hope. It can be kind of depressing when I give a long talk about the changes happening and what can happen over the coming decades and talk about the examples of impacts on the American people. It gets pretty depressing. Our future does depend on how we act. We do have to adapt. We have to be proactive about that. But I also think we can draw on our long history of responding to changing conditions on our planet and facing the challenges of climate change. I continue to have that optimism, and I will thank you.
Thank you, Dr. Webbles. Now we have Dr. Seth Darling.
Thank you, Congressman. So I know I'm standing between you guys and Tom Skilling, so I'll be quick. So Don just started to allude to the question of what is it that we can actually do. So we basically have 3 types of options of actions we can take to deal with this mess that we've gotten ourselves into. There's adaptation, geoengineering, and mitigation. And I just want to say a little bit about each of these. So first of all, none of them are going to be easy. This is difficult. I like this picture. On the road to success, there are no shortcuts, as that truck driver ironically discovered. So first off is adaptation. This is something we're all going to have to do whether we like it or not, because we've already changed our climate so much, and there's so much warming kind of baked into the system already that it's going to change a bunch more no matter what we do, that we're going to have to change how we all live. We're going to have to build more resiliency into our infrastructure to protect our electrical grid, our water systems, and so on. We have to plan for these major impacts like the precipitation events that the previous speakers alluded to. Now, things have gotten so bad that there's actually a lot of serious and smart people talking about doing what is called geoengineering. And what this is essentially using the Earth as an experiment and changing the entire system intentionally. Now, we've already geoengineered by accident by putting all of these fossil fuels into the atmosphere. That's changed the climate in a serious way, as you just heard. Now, we may be in such a mess that we have to actually use the whole ball of the Earth as an experiment and try and change it in the other direction. And there's two ways in which you can do this. So the greenhouse effect is what's driving the warming. Greenhouse effect is sunlight, energy coming in, and then greenhouse gases trapping that energy. And so the two types of solutions are try and block some of that sunlight or try and pull some of the carbon dioxide out of the atmosphere in various ways. And I won't go through all the options that have been discussed, but I guarantee you that almost all of these are going to have all kinds of unintended negative consequences that we don't even understand. So let's hope that this is not what we have to turn to, although we may be in that situation. Now, I want to spend the rest of my time talking about that third category, which is mitigation. This is about reducing emissions, putting less carbon dioxide into the atmosphere. So how do we get into this mess? It's by our use of energy, as we heard about. This is a plot of the rate of energy use worldwide over time. And it's data up through 2018 and then a projection going forward out to the year 2050, shown here. So one thing you'll notice right away is that we use more energy over time. And that's been true since human civilization began, and it will be true for, well into the projected future beyond 2050, what's shown here. So we're going to need to be using more energy in the future than we're using today. This is unavoidable, not just because of population growth, but even more so because of development. As the developing countries, China, India, Africa, Brazil, et cetera, all start developing more, each individual uses much more energy, so energy demand skyrockets. That's where this growth is coming from. That's not going to change. And by the way, just to show you the tight connection between energy use and global activity, you can see this little dip right here. That's the Great Recession. So when global economic production dipped, you can actually see the decrease in the energy use. That's how tightly they are connected to one another. So the bulk of the energy has been fossil fuels. That's the gray part of this plot. And you can see the projection going forward, disappointingly, is that that will still be true all the way through this projected period. That low carbon piece, the renewable energy piece, and nuclear is also low carbon, is way too small in this projection. This cannot be what the energy mix is going to be. What we need, if we're going to have any hope of getting out of this mess, is a huge green wedge going forward. That renewable energy piece needs to be much larger, something like 20 terawatts or more by the year 2050. A terawatt, by the way, is 1 trillion watts. So that's the scale of energy we use in the world. You can think light bulbs are a few watts. This is a really high rate of energy use. Today, we're sitting at about 18 or 19 terawatts. That's going to be 30 terawatts by the year 2050. The bulk of that has to come from renewable sources. So what are our options in terms of renewable energy sources? These are a series of boxes that I scaled in size to represent how much globally you could feasibly get from these different energy sources. And they're not precise. They're plus or minus some amount, but ballpark, the numbers are right. And you'll notice that the different energy sources are not all the same size. Some are just inherently more plentiful than others. So geothermal energy, for example, that's where you're drilling down and using the heat that's in the below the Earth's crust to make steam and turn turbines to make electricity. You can only do that where the Earth's crust is very thin. So Iceland gets a lot of energy from geothermal, for example. But worldwide, the total contribution we could ever get from that energy source is less than 1 terawatt. It doesn't mean you don't use it where you can. It just means it's not going to make a big dent. So this is the box that we have today. I mentioned today we're using 18 or 19 terawatts worldwide. And this is how we fill that box today. This is another way to picture that energy mix that I showed you earlier. And the bulk of that box is fossil fuels, which is what got us into this mess. But there's nothing we can do about today because it is what it is. I have a 16-year-old son. The question is, what about when he's middle-aged in the year 2050, when we're now going to be using 30 terawatts worldwide, remember? What is the energy mix going to look like? And that projection that I showed you earlier looks something like this. So all of the energy sources we used more of them. All those boxes got bigger, every one of them, because we needed that much more energy. But this is actually an increase in fossil fuel use, not a decrease. That cannot be the energy mix in the year 2050, or we're in an awful lot more trouble than we are already today. So let's just take a hypothetical look at this. Let's say we weren't going to use any fossil fuels by 2050. I'm not sure if that's realistic, that we can completely get away from them in that timescale, but hypothetically, what if we could, and we wanted to use only renewable energy sources, how much could we get? So I'm going to empty out all the renewable energy boxes on that screen, all the wind, all the hydropower, et cetera. How much energy is that? Well, it's a lot, but it doesn't fill up the box. All of those together, if we do the wind and the hydropower everywhere we can, geothermal, et cetera, it doesn't cut it. It's not enough energy. But if you're paying attention, you would notice there's one energy source that's a renewable source that I didn't show you yet. There was a missing box. And that missing box was solar. So let's look at how big is that solar energy box, and can that help us fill up the overall global energy demand. So I'm just going to do kind of a rough estimate for how much you can get from solar energy worldwide. So this is a circle. It's just a circle that's too big to fit on the screen. And that's how much energy hits the surface of the Earth from the sun all the time. Huge amount of energy, but of course you can't capture all of the energy that's hitting the surface of the Earth. That's completely unrealistic. So the first thing I'm going to do is I'm going to throw out the oceans. We're not going to put solar panels all over the oceans. So that gets us down to a smaller circle now. That's all the land area, the sun energy hitting the land area. But you, of course, can't cover all the land area either. What's a feasible amount of land that you can cover with solar panels? I'm going to say 2%. 2% is approximately the amount of land in the US that's covered by roads. So it's a lot of land area, but it's feasible. We did it with roads. So now we're down to a much smaller circle. But there's another problem, which is that you can't convert sunlight to electricity with 100% efficiency. There are fundamental losses in that process. You can buy panels for your roof, like the one Don has on his roof, that convert at close to 20%. That's commercially available today. I'm going to be much more conservative in that. I'm going to say 12% as a, oh, by the way, that's what 2% of the US looks like. We're not going to put all the solar panels in west central Kansas. That's just what 2% of the area of the United States looks like. So as I said, you can't convert with high efficiency. I'm going to take 12% as a conservative estimate for what's realistic to achieve. So now we're down to a tiny, tiny little circle compared to that monster that we started with. But that tiny little circle over there on the side of the screen is that yellow box. So this is the feasible solar energy supply. It is more than 2 times larger than the total projected global energy demand all the way out in the year 2050. This is, for all intents and purposes, an inexhaustible energy source. Now, I don't show that to say we should get all of our energy directly from solar energy. That's actually not a good idea. You want an energy mix for lots of reasons. But the point is it needs to be a huge piece of the pie because it's the only one that's big enough to meet all of these needs. Now, you hear some knocks on solar. A lot of people will tell you it's too expensive, and that used to be true. This is a plot of what solar panels cost from the 1970s up through today. Yeah, they used to be, you had to be quite a tree hugger to buy solar panels back in the 1970s, but you can probably barely even see the little bar out there today. They cost truly almost nothing today. It's under $1 a watt. And in fact, most of the cost when you put a system on your home is not even the panels anymore. It's all the other stuff. It's paying the people to install it and so on, the so-called soft costs. So it's not too expensive. The other thing you'll hear about solar is that it's not reliable. The sun's not shining all the time. Well, the sun is shining all the time. It's not shining on your solar panels all the time. There's night, and then there's also, of course, cloud cover. And so you have this unreliability. Well, night and day is predictable, but the cloud cover less so, I guess, unless you're Tom. So if you have a solar plant sitting somewhere, a solar farm, and clouds are passing over, the power is going to be jumping around like that. And that's what some of these dashed lines you see are. However, if you connect on your grid that farm with a farm over here, the clouds are over there, but they're not over here. And so this one might be down while this one's up. And while we connect it to a third and a fourth and a fifth, and you start covering a bigger area interconnected on the electrical grid, and what you get is that nice, smooth, orange plot. So it can become a very predictable energy source. It's not so unpredictable. Same goes with wind, by the way. And the last and perhaps most important thing is that night is a big problem when it comes to solar energy. But there are ways that you can store that energy when it comes in, the extra energy, and then use it later when you need it. And there are many ways that you can store energy. One of the ways is thermally storing it. So you use the sun's energy as heat, not as creating electricity directly in a solar panel. And it's relatively easy to store heat for at least hours or a day. Think of it as like a giant coffee thermos, but scaled up. You can also store it by doing things like making ice when you have that extra energy and then using it to do building cooling later, because building temperature control is one of the big energy uses we have. You can compress air when you have extra energy, and it's easy to store compressed air and then let it out and turn turbines when you need it later. You can pump water up to a higher elevation and just hold it above in a reservoir until you need it, and then do hydroelectric power to let it back down afterwards. This is a picture of the Bath pumping station, the so-called world's largest battery, because they can store so much water in this reservoir and draw power down later. And the one that's really going to be the game changer as battery technology gets better is electrical energy storage. Battery storage on the grid, where you just charge up the batteries when you have the power and draw them back down when you need it. So I want to wrap up with this picture, which Don had at the end of his presentation as well. I love this photograph. This is a picture of the planet Earth, obviously taken from space, as the sun is just peeking up on the other side of the planet. And you see that blue line that rims around the planet? That's the atmosphere getting lit up by the sunlight. And what you see here is just how thin that atmosphere is. It is a razor-thin line around the Earth. So when you go outside here and you look up, the sky looks big, but it's a big planet. In the scale of things, the atmosphere is tiny. And so it might be hard to imagine that we as humans could have changed the chemistry of the entire atmosphere by putting carbon dioxide up there, but when you see it on this guy, you can see it's not that big. It's a razor-thin line protecting us from a very inhospitable environment out there, and we've messed it up. It's time to fix it. With that, I'll turn it over to Tom.
Thank you, Dr. Darling, and I think we all know this man. Take it away, Tom.
Thank you, Congressman. I'll tell you, and thanks for doing this. And thanks for everybody giving up a Saturday afternoon to come and join us. You are wonderful. And thanks to my fellow panelists. We've done programs together, and it's an amazing group. By the way, this gentleman and this gentleman, Doug Sisterson and Seth Darling, have authored a book. We're not here to sell books, but if you ever have been, you've had somebody who doesn't believe climate change is happening, and they give you arguments, which are often specious. This book looks at all of the arguments you've heard about why we're not the ones affecting our climate, and it addresses it in a very readable, understandable, comprehensible manner. It's called How to Change Minds About Our Changing Climate. And it's a great way to address folks who come at you and say, this is all being blown out of proportion. The chicken littles are saying the sky is falling, and it's not really. It's a great book and an easy read, too. And I was thinking about what Seth said about the thinness of our atmosphere. We talked a couple of years ago, and by the way, Don Wubbles was one of the scientists who worked on the passage of what's called the Montreal Protocol. Remember we talked about the hole in the ozone layer and the aerosols that we're using to propel fluids out of cans? These aerosol propellants were made of chlorofluorocarbons, and they would migrate into the stratosphere, the layer above us, where the ozone layer is that protects us from ultraviolet radiation, and they were destroying that layer. Now, the layer looks fairly thick when you look at it on a graph, but if you took that ozone layer up in the stratosphere and brought it down to the surface, it's only 2 centimeters. That's a little under an inch thick. And so it gives you an idea of the scale that we're talking about and how easy it is to damage these critical layers of our atmosphere. I wanted to show you a couple of videos I thought you might find kind of interesting because climate change is real and happening. This is a look at what happened in Greenland this past summer. You know, our Arctic is in a meltdown phase, and the amount of water escapes us because we don't live near the Arctic and we can't see it happening. They had a heat wave that started in Europe, set all-time record high temperatures, 115 degrees in Paris. They set records all through Europe. They had drought, they had river levels low, they had to close nuclear power plants because the water needed to cool the plant wasn't available. And this heat wave migrated westward over Greenland, where the temperature at the lower elevations reached 72 degrees. And there you see some of the meltwater coming in 1 day's time. This was August 1st, this past summer, which is pretty amazing. One other point, too, you know, a lot of people say, volcanoes produce more carbon dioxide than we do. That's another myth. It's not true. Humans produce 60 times the amount of carbon dioxide, that greenhouse gas, that's released by the volcanoes on this planet. So next time somebody hits you with that one, there's a retort right there, which is based in science. Look at that water, though. They figured 12.5 billion tons of water were released in 1 day's time, and over the 5-day extent of that heat wave, 55 billion gallons of water were flushed into the Atlantic Ocean. And glaciers are melting like this all over the planet, so sea levels are rising. This is going to be a real issue up and down the East Coast. Let me show you another video here. This is kind of neat. As we warm the Arctic regions, the permafrost, which it turns out has stored a lot of the carbon dioxide and methane over the eons, is suddenly being re-released to the atmosphere. So not only do you have increased carbon dioxide warming the atmosphere, there's a multiplier effect because stored carbon dioxide and methane is being released. And what you're finding in Arctic lakes all over the planet are these bubbles of methane, which you can actually ignite. Watch this fella tap that methane in that bubble in a lake up in Alaska, and he'll light it. And methane is a greenhouse gas that's 30 times more powerful than carbon dioxide. Doesn't last as long, lasts about 20 years in the atmosphere. Carbon dioxide, once it's produced, is there for eons. Well, at least centuries, many, many, many generations. But methane, in the 20 years it's there, is 30 times more potent a gas in holding onto and re-radiating heat. By the way, when we frack, they just took an environmental law off, this current administration, that would release, we release methane in trying to get stored oil shell gas. And the previous administration put a law on trying to get companies to tap or cut down on this methane that's escaping into the atmosphere. And you can see it from satellites. You can actually see the hot spots where the methane is being released as shale production is going on. So methane's not just coming out of melting permafrost, it's coming out of this shale oil production, which has had positive benefits in that it provides us a fuel supply, but there are some negative environmental consequences as well. I want to show you a couple of slides here too, and I'll go through these pretty quickly before I commence with my talk. And those are coming up right here. You know, you've been hearing about these high lake levels on Lake Michigan. We don't worry about it here in Romeoville, but in Chicago and up and down and all along the coastlines of the Great Lakes, this is a real issue. Look at the erosion that's going on. The Corps of Engineers just reported Friday, the lake is now 19 inches higher than a year ago. I've been following these reports for decades. I never remember 19-inch higher lake level than a year ago. But what it's doing to our shorelines there is incredible. And people are quick to say, well, what's anybody live there for? Have them move. The problem is when they built their homes there, the lake wasn't collapsing like that because nobody envisioned the kind of lake levels that we're getting now on a regular basis. Here, by the way, is an infrared look at the warming that occurred in Greenland. Greenland has elevations of up to over 10,000 feet in the middle of it. So the coastlines are down at sea level, but there's ice quite high there. The red areas are the areas of the ice in Greenland melting, and you can see it right there. Fires. Alaska lost 2.5 million acres to fires, and in Siberia, in Russia, one of the major fossil fuel producing regions of the world, They burned anywhere from 12,000 to 22,000 square miles in the largest set of fires they've ever had last summer. Putin had to call in finally the army because all the towns in Siberia were choking on the smoke. And in Anchorage, Alaska, where they had never had a 90-degree temperature, in fact, until recently, they didn't have summer thunderstorms. They occurred in interior Alaska. It hit 90 degrees this past summer. One of the many areas of the country or the world seeing record high temps. This is a plot of the distribution of Anchorage temperatures. And let me see if I can get this little pointer to work there. There it is. Oh, sorry. I'm used to this. There we go. I feel like I'm on the air and the computer is just melting down, you know? In my line of work, you're used to a technology failing you, you know? So, but look at this. These are different ranges of temperature, and you see that little bar there? This is since 1953, the record of temperatures in Anchorage. That's the number of 90-degree days they've had. So you know something's afoot when we start getting temperatures like that to show up. Anybody who lives in Chicago has seen this. We have breakwaters that are underwater every time you have a strong north-northeast wind. The folks at the city of Chicago start worrying. The Great Lakes, the past 5 years have been the wettest 5-year period across the Great Lakes drainage basin. Lake Michigan has added 2.335 trillion gallons of water. 27 inches more rain has fallen as the planet warms and holds more water in the past 60 months than is typically the case. And the Great Lakes are running an average of 1.5 degrees warmer. When water warms, it expands, so you not only are adding to the volume of it with runoff and producing this incredible infrastructure damage along the perimeter, but you also are thermally expanding the water, which is what's happening in our oceans as well. This, by the way, was a picture a viewer sent me of the beach at Michigan City back in the 1940s. Apparently her mother and a friend were sitting out there sunning. Look at the beach there. If you go and see that beach now, it may be 100 feet wide. And this picture went, what do they call it when it goes viral? That's it. This is shot by a Danish meteorological crew. They were going with their sled dogs out to retrieve some measurement equipment, and this is the ice melt in Greenland sitting on top of the glacier that they were going through this past summer. There, by the way, is a graph. The gray area is the normal Greenland ice melt. The spike there is that heat wave that occurred in August, and there were subsequent ones after that. Now, here's the polar vortex last year. Remember the president put out a thing saying, where's that global warming now? We could use some of it. And if we looked out our doors, it was really cold. But see that little blue area right there? That was our polar vortex right there. There was another lobe of cold air up there. But the fact is, look at the rest of the world. It was warm, and in fact, warmer than normal. What had happened 2 weeks before that cold air came down last January was the mound of cold air over the North Pole, which was one big blob, suddenly broke into two pieces. There's an event called sudden stratospheric warming. This is where the air 10 miles above the North Pole heats very suddenly. And we think one of the reasons that happens is because storms migrate up into the Arctic regions that didn't used to reach there. And storms push huge amounts of air up aloft and warm the atmosphere. The stratosphere, 10 miles above the North Pole, it heated 100 degrees in 2 days. This split the mound of cold air into two lobes. One crashed down on eastern North America. The other one came down on Siberia, even as the rest of the world was quite warm. So global warming, as it were, it was continuing and just alive and well, even though it was cold outside where we are. This is a look at how temperatures have changed across North America over the last 100 years, and you can see the biggest change, the Arctic regions are warming at more than twice the rate of the rest of the world. There are the ocean temperatures. Last year had the warmest ocean temperature on the planet, and you can see how much of the area is above normal. This is affecting ecosystems. There was a study out from NOAA that the Dungeness crab shells are shrinking. That's because the oceans are also turning acidic as they absorb carbon dioxide. And here's a map of the percent of the ocean surface that's warming, and you can see it shooting up. as we increase our fossil fuel, our carbon dioxide content, just as the air temperatures on the planet are going up. Fires in California. The California fire season is now a year-round affair. It's expanded by 3.5 months, 6 times as many acres burn as did just several decades ago. The number of fires has tripled in California, and there's a view from space of the smoke. The smoke is like a volcanic eruption in the amount of particulates and pollutants it puts in the air. There's a view of the smoke plume from California as viewed from the International Space Station. There's a plot of the acres burned in California. You can see the trend there. And then there's Hurricane Michael, which intensified as these hurricanes have been apt to do in recent years, very quickly because of abnormally warm ocean temperatures. Michael came in and hit northwest Florida, the Florida Panhandle. They had never had a hurricane of that intensity. This past year, we had Dorian that went into the Bahamas, and the year before that, we had Maria and Irma that took out Puerto Rico and the Caribbean islands. But that's Florida from Hurricane Michael. These are the floods accompanying the rains in North Carolina. These dogs, had they not been rescued, would have died because the water level was rising, and the owner had left so quickly. He left his dogs penned up, and the crew came in and rescued them before they were dying. This kitty probably says it all. So what in the world is going on? That was from a hurricane that went into North Carolina. 36 inches of rain. They had never gotten this amount of rain in North Carolina. Houston, Texas, only a year or two before, had nearly 60 inches of rain. That's never happened in a landfalling hurricane, and that's a product of the atmosphere getting warmer and wetter and the oceans warming. These are fires in Scandinavia. There's the heat in Australia. The death of livestock there is tragic. And there are the fires burning, and of course what's happened this year is beyond anything they've seen before. We're getting wetter, percentage of big rains increasing. There is the increase by decade. It's probably the biggest impact that affects all of us in the Midwest. Again, Greenland ice melt. Here's the Arctic ice coverage. So I could go on that, but those are some salient facts on climate change. Well, you know, I've been a frontline broadcast and media meteorologist for the past 50 years, and as a young man, I used to question predictions that the planet's ice sheets would melt, its ocean and atmosphere would warm, and that the consequences of warming would lead to planetary weather extremes in which storms were stronger and wetter, heat waves more frequent and hotter, and extremes of all kinds on all ends of the meteorological spectrum would occur. I don't question that any longer, nor, by the way, does any serious scientific organization in the world. My work as a forecaster means I've watched firsthand as the climate science community's worst fears have unfolded and then some. Climate change is real, it's ongoing, we're paying for it already in billions of dollars of cleanup costs in the wake of growing numbers of supercharged storms, and predictions it will get worse aren't pipe dreams. And to those who say we've always had climate shifts and survived, just ask the Vikings, who landed on Greenland 1,000 years ago during a warm episode and were wiped out within a century when the climate changed, the weather turned cooler. Or ask the American pioneers who settled the Plain States and were forced to, either perished or forced to evacuate the Plain States during the Dust Bowls of the 1930s. That was a short-term climate change. A lot of people think of climate change only in terms of ice ages. There are short-term variations, and these, given our growing numbers on this planet, there are about 7 billion of us, are having more and more impact on our lives. Ask them how climate change worked for them in those areas. Climate shifts are devastating, and never on this planet or in this country have there been so many in harm's ways from climate shifts and the extremes of weather which accompany them. We have millions on our coastline, including in mammoth cities like New York and Miami, who before the end of this century are going to face real issues on sea level rise, and they already are. We're likely to lose the Florida Keys, Cape Canaveral, the Norfolk Naval Air Station, and sections of the New York area to rising waters by the end of this century unless we do something. Climate change has very real-life implications, and on so many fronts. It impacts our economy, our air quality, our health, the health of our oceans, the world's water and food supplies, the spread of disease, whether buildings are built to withstand storms and sea level rise, and even the form of energy we'll tap to survive in the decades ahead. Do you know they estimate 1 billion new air conditioners are going to come online by 2030? How are we going to provide electricity for that and without increasing the fossil fuel output? It's one of the many questions that face us as our numbers grow on this planet. And our oceans are being profoundly damaged as well. 25% of the carbon dioxide and something like 90% of the temperature increase on this planet is being transferred to our oceans, impacting fish and shellfish stocks on which humans and animals alike depend. Oceans today are 30% more acidic than they were at the start of the Industrial Revolution. And it's irrefutable that human activities, and most notably the use of fossil fuels and the greenhouse gases that they produce, are driving the changes. What deniers and dismissers of the impacts of these changes are either ignorant about or dismissive of is the speed at which these current-day climate changes are happening. Our planet, as Don pointed out, is warming at 10 times the rate of anything observed in the past. Ice ages take thousands of years to develop and recede, so there's time for life forms to adapt. Today's changes are occurring in a single generation. Consider just a handful of recent examples. The Great Lakes, driven by record precipitation, are near at all-time record levels. This comes just 5 years after near all-time record low lake levels. The speed and magnitude of the water level swing of the past 5 years sets this apart from others such swings that have happened through the record and will continue and likely to grow wider as climate change produces greater precipitation extremes at both ends of the spectrum, wet and dry. The effects in recent years have been noticeable and demonstrable. Huge stretches of Great Lakes beaches are submerged. They've had to close whole beaches in just the last month because of storms in Chicago. And the city of Chicago has requests in for $500 million to shore up 8 miles of shoreline, and that's occurring all around the Great Lakes. Our area farmers encountered the worst planting season in memory this past year. Fields went unplanted due to flooding and standing water, but here's a stat that really drives home how this is impacting this country's economy. 40% of the income to U.S. farmers in 2019 was from government disaster grants, from insurance, and from taxpayer money to cover the impact of ill-timed tariffs which harmed our farmers' export markets. Flooding submerges swaths of our area with a regularity not ever seen before. 2-inch or greater rains are up 46% here since the 1950s. Our reporters at WGN regularly come back from record floods on the Des Plaines, Fox, and other rivers with sound bites from residents saying this is happening with a frequency none of them has ever experienced before. The American West, as well as Alaska and Western Canada, have watched vast tracts burn. I've showed you Siberia, Alaska, and so forth. Northern Scandinavia burned. The fires in Australia that have been making news are without precedent. It's estimated right now that nearly 25 million acres have gone up in smoke, and the fires are still burning. The season has months to run. It's been estimated 1 billion animals have perished. Pictures of grievously burned and injured animals, koalas and kangaroos among them, and of residents' desperate efforts to save and treat these animals are regular features of coverage out of that area, not to mention the human loss of life. Nearly 1 billion tons of carbon dioxide has entered our atmosphere since September because of the Australian fires. That's as much greenhouse gas as is emitted by all the aircraft around the world in an entire year. And smoke from those fires has been tracked by satellite. It's rounded the globe twice and still is moving around the planet. It remains to be seen what the health consequences of all the smoke will end up being down under to cities like Sydney, which have had air qualities that have been the worst on record anywhere in the world in recent days. Those fires followed record 120-degree all-time high temperatures and years of drought, and they covered glaciers 1,600 miles away in New Zealand with smoke and ash. They've even found carbon from the Australian fires on the ice and snow of Antarctica. Climate change-induced sea level rise means Miami, Florida floods even in sunny weather with irregularity as sea levels rise, and New York City is debating a $119 billion seawall to protect it against storm surges with no assurance that that protection will actually occur, that the wall will be enough and even be effective as the sea levels rise. Now, this is interesting. Humans, whose term on this planet has in geological terms been a veritable flash in the pan, have had such an impact on a 4.5 billion-year-old planet in so short a period of time is remarkable. Humans, our form of life form, have been around only 6 million of the 4.5 billion years the planet's been around. Humans evolved into the form we recognize today in only the past 200,000 years. And civilizations, have existed for only about 6,000 years. So to have had such an impact on a comparatively thin atmosphere, as Seth pointed out, which encases the planet, is pretty remarkable. A lot of people will say to me, how in the world do you think we little humans can have such an impact on something so vast as the atmosphere? Well, it's happened. And all you have to do is look at the traffic on highways in any and every city here and that you visit around the world to realize that the vast majority of the vehicles we see on those roads are pumping greenhouse gases into the air. 28% of the greenhouse gases come from the transportation section. Our aircraft and ships are major contributors, and resources must be committed to figuring out how to make that less so. When you consider that our atmosphere, compared to planet Earth as a whole, is in the same proportion when you hold a peach as the skin of that peach to the peach as a whole, you realize how easy it is to impact that little thin reservoir of air, envelope of air in which we live. We've put more carbon into the atmosphere faster than anything that's occurred over the term of human existence on this planet. Now, the wealth that has been created through the development and use of fossil fuels in the past century is off the charts. Little wonder there's such a pushback at suggestions we make a historic shift from polluting fossil fuels to renewables. I've read only recently that there's concern on the labor side as well. It turns out electric cars, toward which we're all moving, have 1/5 of the working parts of fossil fuel vehicles, making them less time-consuming and labor-intensive to build. This understandably concerns those who work to assemble vehicles in this country, and it's an issue that will have to be addressed. And John D. Rockefeller, the founder of Standard Oil, which started this whole fossil fuel situation we're in, at the pinnacle of his wealth, was worth 4 times the wealth we attribute to the richest men on this planet today. We hear about Bill Gates and Bezos and the billions they hold. Rockefeller had 4 times the wealth, the equivalent of that. Many of the most positive attributes we associate with modern life are the product of the availability of energy that the Rockefellers of the world harnessed and brought to market. But real problems have arisen. Our atmosphere has for centuries been used as a dumping ground for gases and aerosols produced through burning fossil fuels. The resulting greenhouse gases have accumulated to levels which have changed the way heat is distributed through the atmosphere. All weather on Earth, its jet streams, its storms, are driven by differential heating. The fact one area gets warmer than another area. By fiddling with this distribution of heat, we're changing jet streams that deliver rain to our agricultural regions, and also the amount of water the atmosphere can hold. By the way, that this might be a possibility was relayed to fossil fuel companies back as early as the 1960s by their scientists. The public was never informed of this. So, in other words, it's been a long time. We've known since the 1800s that greenhouse gas can warm the planet. So, at any rate, our Arctic regions continue to melt. 666 billion tons of ice melt annually It's meltwater flooding into the world's oceans at a rate averaging 14,000 tons of water per second, a rate which has tripled since the mid-1980s. And we showed you what happened in Greenland. So at any rate, the mess, oh, by the way, one of the offshoots of that, all the water from Greenland has slowed the Gulf Stream to its slowest pace in about 1,000 years. The Gulf Stream is that warm ocean current that goes up the East Coast, goes over to Europe. It's running at its slowest pace in 1,000 years. And this has implications because the water is damming up along the East Coast and sea level rise is occurring faster than it would normally occur. It's also leading to a pooling of the warm water. NASA reports the fastest warming body of water on the planet is the Gulf of Maine, which is in lobster territory up there. So we've got a lot of issues, and I guess the main theme through all this is we've got to get off fossil fuels or reduce our dependence on that. And what's sad is we could create millions of jobs, wealth, and all the rest, instead of buying our solar panels from China, where 75% of them are produced, or our big wind turbines, which, by the way, don't kill any more birds than do fossil fuel plants or nuclear power plants. More birds die in and around fossil fuel power plants than do around these wind turbines, contrary to what's said. But we could make money. These would be American jobs that stay here in the United States, and we could become and should become the world's leader in the new generation fuels, as we have in so many areas through our history. So at any rate, thank you. I'm sorry I went on so long, but I thank Congressman Lipinski again for doing this, Congressman, and for the work you do. It must be awfully hard coming up against some of your opponents in Congress, but this is an important subject. And look at the turnout on a Saturday afternoon. You folks, hats off to you for being so interested to come and listen to a bunch of geeky types talk about climate change, you know, because we take this seriously, and Laura is going to tie it all together here, I think, in a meaningful way. Laura? Oh, shoot. Oh, you need this one? No, all right.
Thank you, Tom, and our last panelist will be Dr. Laura Franklin.
I appreciate being part of this discussion today because I am not a scientist and I am not going to talk about the science. I do want to start with something that comes from a book called The Uninhabitable Planet, Life After Warming by David Wallace Wells. The opening statement he makes in his book sums up what many of us in this room are feeling right now after hearing from my panel colleagues, and that is this: it is much, much worse than you think. So my fellow panelists have outlined just how bad it really is, just how much damage humans have inflicted on the earth. I'm here to shift the conversation to a focus on how much damage humans have inflicted upon one another, and to make the case that in order to adequately talk about and address the issues of climate change, we must also address the human justice issues that are inherently part of climate change. To give you an idea about why climate change and human justice are closely linked, I want to offer this quote from the United Nations Office of the High Commissioner on Human Rights. In full, the quote says, "The negative impacts of climate change are disproportionately borne by persons and communities already in disadvantaged situations owing to geography, poverty, age, gender, race, disability, culture or ethnic background, among others, that have historically contributed the least to greenhouse gas emissions. In particular, persons, communities, and even entire states that occupy and rely on low-lying coastal lands, Arctic and tundra areas, and other delicate ecosystems face the greatest threats from climate change." This quote does a nice job summing up the inherent injustices in climate change that the people who really caused The problems are not the people who will suffer the greatest consequences. Let's dig into that a little more deeply. We've already talked about carbon emissions as being the driver of climate change. There are some sectors of our world that contributes to this. Some of my panel colleagues have talked about transportation. Steel and concrete production is used in construction as a big contributor. Manufacturing, power production, and also food production. But as this slide will show you, this is uneven. Our contribution to emissions is uneven. We know that global wealth is concentrated in industrial and post-industrialized nations. And we know that those are the nations that have ready access to air and ground transportation, to air conditioning for our homes and workplaces, ready availability from food from all over the world. And so it's not surprising that wealth is positively correlated with emissions. As this graphic shows, those who hold the top 10% of global wealth contribute almost 50% of global emissions, while the poorest 50% in the world contribute only 10% to global emissions. Another root cause, a cause of carbon emissions, one cause is deforestation. So I just want to look at that one thing. Some of it is unintentional, right? As you've seen before in Tom's presentation, the California wildfires, the wildfires in Australia, but some of it is quite intentional. And when we lose trees, we lose the ability of the planet to absorb the carbon that we're pumping into the environment. There are, of course, contributing factors to deforestation. And it's happening all over the world, but the place in the world that probably horrifies us the most is the deforestation that's happening in the Amazon. This is a photograph of fires burning in the Amazon just in August of 2019, so just a couple of months ago. Roughly 3/4 of the deforested land in the Brazilian Amazon is used for cattle pasture, and most of the remaining is used for crop production, mostly soybean production. The question we need to ask ourselves is, why is this happening? It all has to do with global demand. Globally, demand for beef increases as prosperity increases. The US is certainly a large consumer of beef, but as Asia experiences increases economic growth and prosperity, the demand for beef is similarly increasing. Brazil has the world's largest commercial cattle herd in the world, and they are one of the largest exporters of soybeans in the world. They are clearing their land at an alarming rate to feed the world's demand for beef and for soybeans for biofuels and other purposes. So we look at consequences of climate change. I've just chosen a few to look at, and one of those consequences as famine. And as is the case with carbon emissions, the consequences are not going to be borne equally by all of us. There's only one cause of famine, and that is that there's not enough food for the number of people that need food. We need to remember that in the world today, we already have 800 million people who are chronically undernourished, and 100 million of those are in that state as a direct result of the effects of climate change. Our global population is growing, and climate change will exacerbate and accelerate the problem of global food insecurity. To understand why, let's take a look. The World Bank, the UN, and other global organizations regularly run global population estimates. This chart shows that, this is from the World Bank, they estimate a global population by the end of this century to reach right around 11 billion people. That's a lot of people. But as population growth goes, this is not going to happen evenly around the world. You see flat population growth in Oceania, North America, Europe, Latin American countries, a slight decline in Asian countries, and a huge uptick in the population in African countries. In fact, African country population is expected to grow 5-fold throughout the course of this century. And this is a part of the world that is already food scarce. For one reason why, let's take a look. Cereal crops, think wheat, rice, grain, soy. Cereal crops feed 66% of the world's population. They rely on cereal crops for food. This map shows you the world's largest producer of cereal crops. So you can see that the African continent is not a large producer of cereal crops. Keep in mind that a large portion of the crops in these blue shaded nations, which are the largest producers, a large portion of these crops are not grown for food. A large portion is grown to feed livestock and also in biofuel production. This next slide shows crop yield loss. So we know that for every degree of warming, crop yields decline by 10%. For every degree of warming, crop yields decline by 10%. The countries shaded in red are the countries which will experience the largest declines in crop yield. If you'll look at Africa, again, who already doesn't have a high yield or a high rate of crop production to begin with, their crop production will get even worse as the planet gets warmer. Again, this is the same area, remember, that will also experience unprecedented population growth. Factoring in the world's growing population, factoring in the decrease in crop yield brought on by climate change, factoring in a growing demand for meat and a growing demand for food to feed that meat, the UN estimates that in the next 30 years, the world will need to produce twice as much food as it currently does. That's twice as much food as it currently does. And remember, as the planet gets warmer, it's harder to produce that food. So when you think about famine, think about what would you do to keep your family from starving to death? What would you do to feed your own family? Due to poverty, unstable political situations, and conflict, people in the Congo are clearing out land by hand for subsistence farms to feed their families. Here's a picture of one such example. Please remember that the rainforest in the Congo is the second largest rainforest in the world. It is experiencing clear cutting at an alarming rate. Over 64,000 square miles, a land area the size of Wisconsin, has been cleared by hand in the last 10 years by people such as these who are just trying to find a way to feed their families. We know that if they continue to clear their land, the planet gets warmer for everyone. But how can we tell them not to clear their land? Another consequence that we will experience unevenly across the globe is flood. A lot of my panelists have already referred to glacier and polar ice melt, warming oceans, and extreme weather as causes of flooding. And so let's look at what that would look like. At just 3 degrees Celsius, which one of my panelists said we're probably headed that direction, at just 3 degrees Celsius, the areas of this globe shaded in red will be underwater. This includes large US cities, think New York City, Miami, New Orleans, Houston, Sacramento, but it also includes parts of the world. Please take a look at the Indian continent, all the islands that make up Indonesia, that simply do not have the resources to cope with that sort of natural disaster. Around the globe, 600 million people live within 30 feet of sea level. So when we think about those people, where are they going to go? Where are they going to go? And when we think about who will be displaced and who will be most adversely affected, let's talk about displacement. Just in 2018, 17.2 million new displacements across the globe were experienced because of the effects of natural disasters. And most of those, as we've heard from Tom, are because of climate change. Another 750,000 people were displaced following drought. And this isn't just one season of drought or 2 seasons of drought. This is chronic drought that many areas of the world are experiencing and will continue to experience. That's a big number of people just in 1 year. So I want to bring it back home a little bit and think about what that looks like on a more local level. You might recognize this. This is a photo taken after Hurricane Katrina in 2005. Hurricane Katrina killed nearly 2,000 people and it affected a land mass of 90,000 square miles in the United States. But the worst effects were definitely found in New Orleans. When the storm hit New Orleans was 67% Black and 30% of its population lived below the poverty line. When the storm struck, many of those people had nowhere to go and no way to get there. The people who made it to the Superdome were lucky, but only 15,000 were let in, leaving tens of thousands of other people stranded. They tried to walk out of the city. They just needed to get out as fast as they could. This storm permanently displaced 1 million people. Why is this important? This is important because as we look at these uneven effects of climate change and say, well, maybe it won't be so bad where I live, we have to remember that we have vulnerable populations even within our own borders. The UN is looking at 70 million people displaced right now, and there are estimates that as many as 1 billion people across the globe will be displaced due to the effects of climate change by the end of the century. 1 billion people. This in a world where we can't effectively resettle 5 million people from the Syrian wars. So the final piece of the injustice puzzle is this. If you look at the top half of this map, the countries shaded in red are the countries that produce the most carbon emissions. The countries in blue are the ones who produce the least amount of emissions. On the lower half of that map, the countries in red are the countries with populations who are the most vulnerable to the effects of climate change. The countries in blue are the countries whose populations are least vulnerable to those same effects. Please look where the red and the blue areas are. This is what injustice looks like. As in all fights in the world, I believe that the people with the power need to choose to get on the side of the people without the power. That's how justice fights are won. And so my fellow panelists have offered some ideas about what we can do. One of them is a huge idea, and it's not a new idea, but it's basically decarbonization of the economy. As long as economic prosperity and carbon is tied together, we will have a hard time winning this argument. We also do need to remember, and I encourage you to remember, that behind all the science and all these effects about warming and what we're doing to the planet, there are people underneath every single one of those statistics, real human people. And if you're interested, I would encourage you to go to this UN website, and they will send you push notifications every single day of a small step that you can take to reduce your own carbon footprint and hopefully lead to a more sustainable world for ourselves and for our fellow humans. And I want to leave you with one final thought. And this has already been said before, but I just want to bring this home. The planet was around long before the humans were around. And the planet itself is going to survive. This big globe we're on, it'll still be here. It's really the humans that might not. Thank you.
Thank you, Dr. Franklin. We now have some time for Q&A, and the way we're going to do this is to, if you have a question, if you can text your question to that number, and then the questions will, that's how the questions will get in. I'm going to start by asking a couple questions, just give people time to write their questions in. I want to ask, this is actually a question I had before I even knew the book here. So Dr. Cistern and Darling, if you could each give me one myth that has not been debunked yet here today, because again, that's the big thing to me, is where I sit is being able to make the arguments and debunk the myths. So I look forward to reading the book, but each of you could give us one.
Go ahead, Doug.
Well, you start.
All right, I'll go first.
Is there one?
Yeah, one of the more interesting angles is as the scientific case demonstrating that the climate is changing and that we are at fault becomes really difficult to argue with because there's just so much evidence now. An interesting tack that the skeptic community has taken is to say that climate change, sure, it's happening and yeah, it's our fault, but it's actually not a bad thing. And it is true that you can point to, some localized ways in which some localized communities might win, some land that's not currently arable might become arable as warmer temperatures move further north, for example. But it is unquestionable, as you heard probably more than you wanted to just now, just how bad this is really for everybody. And even those local wins are temporary wins, and in the long run, everybody's going to lose.
So that's a big one, that this fertilizing from additional CO2 is not a great thing. It does have a small impact on plants, but it also more affects weeds and bugs than it does crops. So the net effect is that CO2's biggest effect is to drive for changes on climate. When we released the National Climate Assessment in 2017, 2018, the 2 volumes, Sarah Huckabee Sanders in the White House made 2 statements, one of which was, it's just only based on high unreasonable emissions, and secondly, that there's no data involved. I hope you saw today that first of all, that this is entirely based on data. Many, many millions of observations made around the world from a variety of different sources. And secondly, that we looked at a range of scenarios, not just a high scenario.
Yeah, I was thinking about that. What's in the book? I mean, there's things we've talked about. One of the interesting ones is probably what you might have heard is ClimateGate, where deniers got in and tried to discredit actually some of the assessment reports by some emails that were found.
No, we're stolen.
Stolen, yes. Not stolen, yes. And I think the issue here is that climate scientists, there's probably about 3,000 climate scientists around the world that I would call are subject matter experts in climate. And we've all seen some of the documents that said, there was a group that signed it that indicated that they were scientists that were willing to dispute the claim of these other climate scientists. And some of them were, the list, when you examine the list of people that were put forth, some of them were deceased, some of them were the typical type of just lies that get into things like this. And we talk about those. We talk about those and the facts about how we can go through and show that was completely disputed. But I think the most interesting thing is that even though we wrote this book about, 5 years ago? Something like 6 years ago, maybe? It's still to date, because there's only about a dozen to maybe 15 climate denier arguments. And the interesting thing is they have not changed. They have not changed at all. So there's nothing really new out there. And if you kind of want to learn about some of the things that have happened.
Say the title of the book again.
It's called How to Change Minds About Our Changing Climate.
May I add one other thing about this? Rupert Murdoch favorite is that carbon dioxide is plant food.
Yeah, so
They've
that's-
done studies on that, and they've shown that the nutritional yield in crops grown in a higher CO2 environment drops, which is a real concern because rice is a mainstay of
another
many
concern.
diets in the world. The nutritional value of a rice grown in a high CO2 environment actually drops. And beyond that, the problem with CO2 is, along with it comes heat, and that reduces yields in lands that are produced under high CO2 environments. So this notion that everything's going to get better because we're putting more CO2 in, and that anybody who doubts that is one of these, the sky is falling folks, is crazy. One other thing I'd like to say, consider the sources. When you have somebody stand up on a medium, a mass medium, and say the climate science community is crazy, this isn't happening, it's all being hyped, ask what their backgrounds are. That 31,000 member scientist list that was supposedly signed by people who had a BS in science, and as a result of that, we're questioning climate science. I say to you this, not all scientists are created equal, nor are they in the disciplines that have anything to do or any complete knowledge of how the atmosphere or our climate system works. For instance, would you go to a dentist who had studied seismology or geology? No. They're all scientists, the seismologist and the geologist, but the dentist has a particular area of expertise in the area of dentistry. These ones who you hear, the Limbaughs, the Hannitys, the other, they have no background in scientific science, and yet they parade these people out who claim that this is all a farce, and these people have no background in science. It's pretty amazing, the audacity to get on a mass medium and get up and debunk a science that they have no background or expertise in. And one other thing I'll say, and because I kid Don about this all the time, another thing you hear is, they're doing it for the grant money. And I keep asking Don, and I should ask Seth and Doug, where are the luxury yachts and the cars and all? If you're swimming in so much,
I'm still waiting for that
I
check.
know, I know. Here we have a downstate Illinois farmer at his core, and believe me, he's not getting rich. Here's one other point. Do you know that people who write these reports that Don is talking about, they're not compensated for that? Don volunteers his time. The United Nations group that puts out these reports, these are all scientists who do it unpaid. Now, they're supported by their institutions in doing their work, but they, as a sidebar activity, take on producing reports. They're not getting rich off this. The money motive isn't there to debunk, or to put out myths. So I just thought that was kind of interesting, because
I was going to say we probably should add one more chapter as I was sitting here thinking about
Yeah.
it. Because in the last couple of years, we've had, there are scientific facts, and now there are apparently alternative facts.
right.
And that's an issue. Actually, it was given to Kelly Conway. It was quoted, given credit for that quote. But I think that's the hardest part, is me personally, as a climate scientist or a researcher, is that today, as Tom pointed out, if your car is broken, you don't go to a heart surgeon, and a heart surgeon doesn't go to a plumber if they've got another problem that's with the human body. The point is that with alternative facts, is that somehow we've been conned into believing that there are another set of facts called alternative facts. This chapter would be very short if we just added to it, and in polite company, it is just wrong. They're just not facts. They're lies.
Doug, one other note, and I should have said this before, and then I'll be quiet.
No, you won't.
The 31, I know.
That'll
I'll
be
tell
the
you,
day.
heaven forbid, right? But the 31,000 scientists, somebody looked at that list. They had the Spice Girls' names on it.
Yeah.
They had, and then they looked at the percentage of these 31,000 scientists who have any atmospheric science background. You know how many of them did? 1/2 of 1% of those 31,000 scientists who signed that petition had any background in atmospheric or climate science, and yet they were there debunking the whole science that the people you see on this stage have spent lifetime studying, and they're telling you it's all garbage because they have a BS after their name that has nothing to do with climate or atmospheric science. So it's important to question the list, and I'll tell you, we're here with a politician, with Congressman Lipinski. Thank God for people like Congressman Lipinski, but this is not a political issue at its core.
That's right.
The policy that comes from it is where we have to get our elected officials involved. And people like Congressman Lipinski are involved. And we work with other Congress people that are involved too. They set policy and try to figure out how to steer our country in the right direction, knowing what the science community is providing them. But the minute I start talking climate change, people say, oh, I don't want to get into politics. It's not politics. This is a global warming is a scientific fact. There's, as Don would say, there's no other side to the issue. And, you know, and I think that's an important point to make. And now I'll be quiet.
98% of climate subject matter experts agree with everything that you've heard here today. It's published in a very conservative report called by the International Panel on Climate Change, and Don has been one of these lead authors on the assessments. 98%. 98%. I defy you to find anything in this world where you can find agreement with people at 98%.
All right, our next question is, how quickly
Well, may I make a point after that? And that is that none of the scientists on this stage have taken a dime from companies that promote climate change. And secondly, it's pretty tough to be a politician. And I'll tell you, and wading through the money that you need to stay in office. And I'll tell you, all I can say is it's Congressman Lipinski that put together this forum to try and educate folks on climate change. And
I would say, too, that we still can't erase the facts about climate change, and we still need to remember that all the impacts, as I said, are impacts on humans. And that's really where the focus needs to be. And it doesn't help to politicize the issue, no matter what your stance is on climate change.
Just want to add one more angle on that, which is that you really can't, none of us can point fingers when it comes to who's at fault here, because we are all beneficiaries of this energy that we've been burning, which has resulted in those carbon emissions. So
We're all at
it is all of our fault.
yeah.
Remember your mom and dad told you that when you're pointing your finger at somebody, 3 fingers point back.
I know.
Thank you. Well, now we'll move on to the next question. For Seth, how quickly is solar energy being adopted, and how can we help increase solar adoption?
Yeah, great question. So it is, you know, I don't give investment advice, but it would be a good thing to invest in because it's growing like gangbusters as an industry. The problem is that we need it to grow like gangbusters times 10 because of the pace of the climate change that's in front of us. And every year that we are slow in getting our act together, we have to be that much faster in the coming years because the climate's changing more and more. So it's growing like crazy, especially because there are places where it's already the cheapest form of energy. So places where it's very sunny and the electricity on the grid is high. Hawaii is one of the best examples of this. It's actually the cheapest option, and so it's growing fast. One of the interesting angles on this, I'll make a pitch for this since I work at a Department of Energy National Laboratory. Most of the panels that you put on rooftops, like those that are on Don's rooftop, are made out of silicon. It's like 95% or more of the market is made out of that material. There's great things about silicon solar panels. There's lots of silicon on the planet, so we won't run out of it. They're efficient and so on. They last a long time. The challenge with those solar panels is it takes a lot of energy to manufacture them because you need crystalline silicon and it has to be super high purity. And to get super high purity crystalline silicon takes a lot of energy. So you plug in your solar panel and you got to wait a while till you get back the energy that it took to make the thing. That amount of time is a few years. Now those panels live for 30 or 40 years, so you're going to get back in the long run much more energy than went into making them, but there's a delay. And because of that delay, it could limit how quickly we can ramp up the use of solar energy worldwide. What we need are new solar panel technologies that take less energy to manufacture. And there are lots of people working on that, including at Argonne National Laboratory. But what we can do is to continue to support that research community to develop those new technologies.
I just heard from a senator that we're going to hear very soon about a new breakthrough in solar technology, but I have no idea what it is.
So, yeah. All right, a question for, I'm glad someone else asked this question because I was thinking about it and I wasn't sure if I'd ask it, but Dr. Robles, how much effect could melting ice glaciers have on the salinity of the ocean's conveyor belt? What can this mean for global weather phenomena? This is something that I've heard about how it's possible that the currents, and I'm blanking on the name. What am I?
The freshening of the oceans? Is that
No, the
Ocean currents.
Oh,
It's the,
Conveyor belt.
it's the
Yeah.
ocean conveyor belt.
yeah.
the Atlantic Meridian overturning
Circulation.
Yeah.
Circulation.
Yeah, I was just avoiding the technology.
I know.
Yeah.
So how serious is that potential? And because it seems like if you stop those, that's gonna. I mean, the impact has to be humongous. I mean, even much bigger than what we're talking about here.
Yeah. So in the assessments we do of climate change, we mostly go out to the end of this century because things get really uncertain after that. But we have some inklings what may happen beyond that. So you already heard me say earlier that we're expecting 1 to 4 feet of sea level rise this century. There are changes going on in Antarctica, in West Antarctic ice sheet, with the melting of ice in the ocean that is holding up a large amount of ice on the side of a very large mountain in Antarctica that could cause sea level rise to be as much as 8 feet. So we talk in the assessment about risk analysis, that if you're going to do risk, you really ought to consider as high as 8 feet for this century. And you're going to see more of that, as Tom implied, on the US. Now, Tom also mentioned that the Meridional circulation is slowing down in the North Atlantic because of all the fresh water that's being added there from melting glaciers and melting sea ice, et cetera. And that is changing the circulation in the ocean. We do not think that that will mean a stoppage of the meridional circulation in the ocean, the conveyor belt, this century. But it could happen over the next 2 or 3 centuries or so, or certainly by over the next 400 or 500 years. And if that occurs, that's going to make the East Coast actually potentially colder than the very warm temperatures you're going to see around the planet. It could also make England and up in Scandinavia much colder than they are now. And so you could have isolated areas that actually get colder because of changes in the circulation in the ocean. But we don't think that that's important during our lifetimes, but it is something that we're worried about and we're trying to understand better. And yes, if that as that continues to occur, it will affect weather patterns as well.
What estimates do we have of the economic consequences of climate change? Who would like to answer that?
There's been a number of studies published. The first one was the Stern report back several years ago, where economists tried to look at the impact of
10
all
years
of these extreme weather events, for example. Just to give an example that even economists now, what we're seeing is that you have normal weather extreme events that happen. The 100-year event should happen every 100 years. But it's when the 500-year event or the 1,000-year event starts to happen far more frequently than the 100 or 1,000-year events. And so economists have been able to actually look at the impact of the addition of the climate change on making storms more powerful, and looked at the increased economic cost of a storm because it has been an extreme event that's been fed by climate change. And a couple of years ago, I was looking into this for some comparisons that I use in class, and basically, to put it in perspective, that Don showed these storms that are the $1 million, the billion-dollar events. At the same time, those storms in today's dollars compared to earlier, when you include the impact of climate on top of that, gives you some idea of the cost. At one point, it was estimated that if we did something with climate change right now, it would take about 1% of the GDP to really invest into alternative fuels to make things work. If we don't, the financial impact of these extreme weather events and climate change will cost 10% of the GDP by the end of the century.
We did analyses for the first time in the 4th National Climate Assessment about the impact of climate change on the U.S. economy. And for the end of the century, the best analyses right now, and I think they're actually underestimates based on looking at them closely, that they're still underestimating various effects, is a 3 to 10% impact on the GDP.
All right, I think this is probably the last question. How acidic will the ocean get by 2100, and what are the consequences of that? I know there was talk about acidification, but what exactly is that going to mean? What will be the impact?
Well, it really depends on how much CO2 we continue to emit. So that's 25% of the carbon dioxide we emit into the atmosphere goes into the ocean, where there it turns into carbonic acid, and it's acidifying the oceans, and that's affecting shellfish and other life forms. I don't know exactly what the estimates are for the pH by the end of the century. I probably should remember that, but
It's about 7.6, well, under high emission scenario.
Yeah. So certainly,
It's currently 8.1.
make the oceans less basic, and by quite a bit. And the potential impacts on life in the oceans is not known, but there's a lot of fear about it.
Affects shellfish is an understatement. Their shells dissolve in
Yeah,
the
they
acidic water,
dissolve.
so yeah.
Yeah, exactly.
I think the point is also I kind of think of the ocean as the blue heart of the planet. It's kind of saving our butts right now because of all the global warming. Water has the highest heat capacity, so it's taking up 93% of the heat that's generated by the atmosphere. So this 1 degree
that's
C increase in atmospheric or global temperature would be a whole lot more if the oceans weren't absorbing it. And the other thing that's important about the oceans, they do take up 25% of the anthropogenic emissions. But as the oceans become more acidic and as they become warmer, they're going to take up less carbon dioxide over time. So the blue heart of our ocean, or our planet, is saving our butts right now, but as we keep putting more carbon dioxide into the atmosphere, its ability to save us will dwindle. And that's probably the largest thing in our planet right now that's not contributing to what I would call almost runaway climate.
Go ahead.
My name's Don Lupe. I went to school here about 50 years ago. Very good. Back in 1970, me and
Thank you.
You've got a pretty good environmentally loaded record. You're pretty highly rated for environmental loading. But you still vote with the oil companies on some things.
All right, I think we've heard this already, and I appreciate your
Let me finish.
opening.
So, I appreciate that you're voting environmentally, but what we need to do is, like Jacques Cousteau said, we need to listen and we need to do something. So what we have to do is limit fossil fuel use, and you have to do more to stop that, and we have to encourage renewable energy. Now, for Lewis College, who's here from Lewis? You're from Lewis, or is there anybody that's a boss, any management here?
I am.
Do you have any idea how much the electric bill is here a year? Then hundreds of thousands.
No, but I know that we just are putting in a solar array that should be finished by August and that'll take a lot of our electricity off the grid.
That's what I was gonna suggest. You have enough property here to power this whole institution and probably Romeoville. And you can put a lot of solar projects in property. So in the words of Jacques Cousteau, everybody, listen and do something. And I thank Lewis for doing something.
Thank you. And I want to give any of the panelists have anything, closing remarks? Does anyone,
What's that?
any closing remarks?
Well, I think the big thing is we all need to be doing something. And I should just add, the University of Illinois is in the process of designing its third solar array to now put in. So we're trying to do something there. You know, we want to see that go to 100% of our energy. We're not there yet. And it's going to take a while, but we're working on it.
Well, I think Lewis could power this whole area. They got all this property. There's a lot of square footage for solar arrays. And in fact, you could make money off it. You could sell the power back to the ComEd. Lewis could finance this place with solar power.
Anyone else?
Well, you know, I'll tell you, I think the most important thing any of us can do, and we've certainly had an education over the last 3 years of how important it is that we do our due diligence on who we send to represent us in Congress. And we need to vote. We need to be sure that the people that we're putting in there have our interests in mind and the environment, because there are certain things I can't build a non-polluting car. I wish I had that ability. There are a lot of things I can't. I just flew to the Maldives, which I know I wanted to see an island chain that's going to go underwater. I wanted to see what it looked like. They're only 4 feet, 11 inches above sea level. They're the lowest lying island, but I know I left an incredible carbon footprint going down there. I bought the carbon offsets and all, but I'm not sure how much that does. It shows how important it is that we send the appropriate people to represent us in Congress, that we support the work that's going on in our national laboratories by our researchers, because it will be from these institutions that cleaner technologies will emerge. And you know, most of us can't build non-polluting cars or appliances. We need help on this. And that's why government is so important, because the money they can bring and the influence they can bring to bear on companies to do the right thing in developing cleaner fuels and cleaner appliances is unparalleled. And so it's incredibly important. It is amazing to me that we have nobody on the cabinet of this administration that has any atmospheric science background and is allowing some of the statements that emanate. I get environmental newsletters every day. The dissembling that's going on in the name of deregulation in our environmental policy in this country is tragic. In the last week, we've said it's okay to pollute our streams and rivers. We're opening up our national parks to drilling. It is an outrage. They're talking about drilling in the Arctic Refuge, which is an incredibly sensitive environment. what we ought to be doing is listening to Seth and redesigning the electrical grid so that we start getting more renewables involved in this and doing it on a huge scale, because we're going to have to do that, as Seth has pointed out, in order to get us out of this mess. At any rate, I just think the people we vote for are critically important. And Congressman, I thank you. It's you do not have an easy job. I thank you for holding a forum like this and producing a forum in which people like a Seth Darling, a Don Wibbles, a Doug Sisterson, Laura can come and talk and interface with the citizens of this country. And we need to be educated. And this forum offers us an opportunity, so thank you.
Well, just a couple of comments as we end here. The politics of this are, like I said, it seemed like we might be getting somewhere more than a decade ago, and that quickly seemed to end. I had a colleague, as I said, in 2009, I introduced a carbon fee bill with 2 Republicans, Bob Inglis and Jeff Flake. Okay? And I thought this is the way we're going to bring the 2 parties together on something that we can agree on, a way to seriously fight climate change. Bob Inglis lost his primary. He's represented a district in South Carolina. He lost his primary badly. And he said when he looked at it, it was all because of one issue. He did not vote for the cap and trade bill, but he said what lost him the primary was the fact that he said climate change is real and it is man-made. That was it. Yeah. And that was the politics that he was facing. And I have a tremendous amount of respect for Bob. He has made his career now since he lost that primary in 2010. He goes around the country and tries to encourage, specifically goes to Republicans, conservative groups, to try to encourage them that this is a serious issue that we need to take serious action on. And so I always have a tremendous amount of respect for Bob, and I saw what he went through. But it's just a story about how tough it is, especially, you say, on the Republican side right now. But this is such a critical issue that we need to take action. And so I learned a tremendous amount here, listening. I look forward to reading the book because I love learning. To begin with, I was a professor. I love learning, but that's the way that we're gonna make an impact. I mean, yeah, we're gonna have a lot of trouble fighting against fake news, alternative facts, but we can't stop. Can't stop fighting, and that's why I was just so happy. I want to thank all of our panelists who were here today to talk about this, and thank you for all the work that you are doing in your careers dedicated on this issue, and thank Tom so much for being willing to come here today with your very busy schedule and spend all this time with us, and all that you do to alert people and wake people up about this issue. So the very last thing before I forget, the Citizens Climate Lobby is having a reception here. I think it's across the way in the DRC Great Room. Yes. So Citizens Climate Lobby, who is trying to motivate people, especially behind a carbon fee, they're having that across the hallway over there. So if you want to stop by, but thank you all for being here. Thank you again to Lewis University, and let's go out and keep fighting.
Sure. Thanks for coming, everybody.
Don't worry.